Okay, so now on page 29, we're going to look at another word problem. And this one, the graph's going to look a little different. And before we read the problem, let's look at the two equations. This is one equation, this is the other equation. Notice this time the slopes are different, but the y-intercepts are the same. So let's see how that will make a difference to our graph and to this problem. Okay, this says I went to a concert where I paid $60 for the tickets for my family. Parking cost $4 an hour, or $4 per hour. So this is going to be the slope. This is going to be the y-intercept, the constant. Okay, and I paid $6 an hour, so that will be per hour, at a lot that was further away. So that would be the slope too. This situation can be modeled by two different equations. So we have, and let's put these in different colors. We have C equals 4H plus 60, so the $4 an hour lot. And C equals 6H plus 60, so the $6 lot. Okay? So this is going to be hours. This will be cost. And obviously the minimum number of hours would be 0, and we'll count by ones. Let's go up to 5. So let's figure out, if I put 0 in for H here, 4 times 0 is 0. So this is 60. This would be 64. This would be 68. This would be 72, this would be 76, and this would be 80. Because when I plug in 4 times 5, it's 20 plus 60 is 80. So let's see how that compares to this. So again, hours, we count by ones. And this is cost. And if I have 0, this is 60. This would be 66. This would be 72. This would be 78. Notice it's going up by 6. This is 84, and this is 90. Okay, so the total cost, again, we go on the y-axis, and we know that time, or in this case, hours, would go on the x-axis. Again, we know we're only going to use quadrant 1 because cost in hours only makes sense when they're positive. So I have to label both my x and y axis. And now I have to figure out my increments. Well, my increments for hours is easy. We just counted by ones. Now, my increments for cost is going to be a little bit harder because one's going up by 4, one's going up by 6. But they both start at 60. So what I'm going to do is use a breakpoint and make this 60. And I'm going to actually count by 2s because that will cover both 4 and 6. So this would be 62, 64, 66, 68, 70, 72, 74, 76, and 78. Okay, so now I'm going to graph and see how these two look. So the red one will start at 0, 60, 1, 64, 2, 68, 3, 72, 4, 76, and I'll just approximate there, and we'll draw the line like that. Now the blue one, we'll start here, make that blue, and then 1 is 66, 2 is 72, 3 is 78, and it looks there. So what you can see from this line is that the more we go, the wider the difference between the two. Here, the difference between the cost 60 and 60 is 0. Here, the difference in the cost is 2. Here, between 68 and 72 is 4. Between 72 and 78 is 6. This is 8, and this is 10. This is the difference in cost. So you notice over time, the difference gets greater. Now, this says, what does the slope represent in this case? So remember from the previous problem, slope is the change in y over the change in x. In this case, y is representing cost, x is representing hours. So the slope is the cost per hour. And what does the y-intercept represent? Well, what does the 60 represent in both cases? The 60 is the ticket cost. So your y-intercept is always going to be a fixed cost, like your fixed starting cost, and the slope is going to be something per something. Okay? Now, the next question says, how does the cost change from 1 hour to 5 hours? How can this be explained? Well, cost increases over time. The difference increases over time. And why is that? Because there's different slopes. So when you have different slopes, the lines move apart as time goes on. Okay? So now I want everybody to try page 30 and 31 on your own. You're going to see that 30 has the parallel lines where the cost stays the same over time. And 31 is an example of different slopes, so they change over time. And I will post in the stream an answer key for both of these pages.